Rewrite and simplify radical expressions. So this is your class notes, and the first problem asks us to show that the following are equal using properties of exponents. What that means is you can't just plug it into your calculator and go, yep, they're equal. You got to show that you understand through the process. So here's what we're going to do. I'm going to use red to represent the left-hand side. So 64 raised to the 4/3. When you evaluate this, you always take the bottom number first. So I'm going to evaluate 64 to the 1/3 power, and afterwards I'm going to take the top number of the fraction and then apply it. If you look on the chart from Monday and find the third column, I want you to locate 64 and then see what is 64 equal to. If you don't have that chart, another way you can do it is to plug it in. So I'm going to type in 64 in parentheses and raise it to, in parentheses, 1/3. 64 to the 1/3 power is equal to 4. This portion equals 4. Now I'm going to apply the 4 up top. A lot of times students think 16. This is not 4 times 4. It's 4 times 4 times 4 times 4. So 4 to the 4th is equal to 256. Now I'm going to go ahead and move on to the right-hand side. So I'm going to first apply it. I could reduce this, but again, I want to use properties of exponents. So I'm going to first apply the bottom number in the rational exponent. So 4 to the 1/2. On Monday, we learned that when you have a number raised to the 1/2 power, it represents a square root. And you know the square root of 4 is 2. 2 to the 8th is not 16. Again, it's 2 times itself 8 times. Using a calculator, I'm going to type in 2 raised to the 8th. The answer is 256. So the two are equal. Moving on to number 2. Which step was there an error made? Explain what the mistake was and then evaluate it correctly. And I find it easier sometimes just to look at the problem and start to evaluate it and then glance over to the left-hand side as I go through this. Notice there's no nth root shown. When you don't see a little number here, that means there's a hidden 2. So if I take this and I rewrite it, the nth root always goes on the bottom. In this case, the top number is 5. Okay, I see that? Okay, I mean step 1 and step 2 are correct. Now how do you evaluate this? We're going to evaluate the bottom number first. So 16 raised to the 1/2, and then we'll apply the 5 afterwards. Just like I said in the previous problem, any number raised to the 1/2 is like taking the square root of that number. So the square root of 16 is 4, and then we'll do 4 to the 5th. 4 times itself 5 times is the same as 4 to the 5th, and 4 to the 5th is 1024. Okay, so here we go. I rewrote it. There we go. Now the third step, I can see there's an error. So what step was there an error made in? The third step. What was the mistake? They forgot to write the nth root as 1/2. That was the mistake that was made. And then we evaluated the problem correctly. Number 3. Number 3 is like number 4. When you're multiplying and you have the same nth root, there's a couple things we can do. So we're going to start with the numbers out front. 2 times 3 is 6. I personally like to cross out the 2 and the 3 then, so there's no confusion. I've already used those. Then the next thing we're going to do is we're going to take the large numbers inside, the coefficients inside the radical. 16 times 2 is 32, and now I have to apply that nth root. What is 32 to the nth root, the 5th nth root? Well, remember, another way to look at that is to write 32 to the 1/5. If you have that paper out for Monday, look in the 5th column and find 32. Once 32 is located, you'll see that 32 to the 1/5 is equal to 2. If you do not have that paper, another way to do that is to type in 32 and raise it to, in parentheses, 1/5. You still can get the same answer of 2. So 2 times 3 is 6. And when I took care of 16 times 2, and I raised it to the nth root of 5, or 1/5 in rational exponent form, I received an answer of 2. I've taken care of these. I don't want to be confused. I'm going to cross them out. Now I'm going to take care of the exponents.
Hey, did you come to work order recently? All right, they gave us the wrong number.
Where's my Gatekeys class? Oh, he turned the afternoon, huh?
Okay.
Alright, well, I'll check back with him.
So a to the 4th times a to the 16th. When you're multiplying and you have the same base, you're going to add exponents. So 4 plus 16 is 20. I'm going to do the work off to the side. So a to the 20, again 4 plus 16 is 20, but then I have to apply this nth root. And what you do is you put that nth root on the bottom. And so when I reduce 20 over 5 is equivalent to 4. That's pretty confusing. Let's talk about that again. A to the 5th times a to the 16th. So same base, you add the exponents to get 20, and then divide by the nth root. And the only way we can do this, again, is when we're multiplying and we have the same nth root. Let's do b. So same base and multiplying, 25 plus 5 is 30. Now underneath the 30, we're going to put the nth root, which is 5, and 30 divided by 5 is 6. Same concept for number 4. They're just trying to make it a little more difficult using fractions. So feel free to use the calculator, or we can do it like this. 2 times 1 is 2. 3 times 4 is 12. 2 over 12. Well, 2 goes into itself once. 2 goes into, divides into 12 6 times. So when I multiply the two fractions, and I'm going to cross them out so there's no confusion, I received a reduced answer of 1/6. Now, 3 times 27 is 81. 3 times 27 is 81, but I have to apply this 4th root. Remember, another way to write that is 81 to the 1/4 power. You can refer to the chart from Monday to find the answer, or you can use your calculator. 81 raised to the 1/4 power in parentheses is the key, gives you an answer of 3. So I've taken care of the coefficients inside and the fractions on the outside. Now we're going to look at the variables. Same base and multiplying. 5 plus 6. 5 plus 6 is 11. Now underneath it, I'm going to put the nth root of 4. 11 over 4 does not reduce. Moving on to the b's. Both have a b and I'm multiplying, so I add the exponents. 11 plus 12 is 23. Underneath, I put the nth root of 4. 23 over 4 does not reduce. And the last thing I need to do is take 1/6 times 3. And maybe you can recognize that as 3 over 1, or you can use a calculator if that's helpful to you. So 1 divided by 6 times 3. You could put 0.5. I prefer it to be a fraction, so I'm going to hit the key that says math on the calculator, enter for fraction, enter once more, and I can see that 0.5 is equivalent to 1/2. They are both correct answers. So when I combine and reduce this portion, I get 1/2. I bring down the A, and I bring down the B. Moving on to number 5. Number 5 and number 6 are alike. I think it's very helpful to have out the paper from Monday. I believe that it's simpler to learn this by switching from radical form to rational exponent form. So 5 raised to the 1/3 power, not to the 3rd power, common mistake, and 108 raised to the 1/3 power. So I just rewrote it in the equivalent form. Now if you look on the chart from Monday, you're going to find in the 3rd column there's no 108s. So how do I turn this 108 into something else? So Sebastian, are you looking at your paper right now? Can you find the third column for me and just correct any mistakes I made? So the first number you're going to see probably is going to be an 8, right? And then 27, 64, right? 125, 216, 343. Okay, and it keeps going on and on. So I want to know, what can I do to the 108 to turn it into one of these numbers? So the way I'm going to look at it is I'm going to go, okay, 108 is going to be right about here. If I put this into numerical order, 108 would be right there. And I'm going to start dividing each one of these divided by 108 until I come up with an answer that's a whole number. So 125 divided by 108. Make sure you can see the calculator. It does not give me a nice, pretty whole number answer, so I'm going to go on to the next one. The next one is 216. 216 divided by 108. This does give you a nice answer that's a whole number. This tells me that 108 times 2 is equal to 216. So I'm going to take times this fraction, 2 in the top and bottom, and you have to insert the same rational exponent. So we're multiplying a quantity. Really, this quantity is equal to 1 because you have the same value on top as you do on the bottom. So it's not changing this original value. When you multiply, because you have the same exponents, 5 times 2 is 10 raised to the 1/3. 108 times 2 we just learned was 216 raised to the 1/3. Again, go back to that paper from Monday and find 216. Once you locate 216, you can see that 216 to the 1/3 is equal to 6. If you don't have that paper, you can take 216, raise it to the 1/3 in parentheses, and you still get the same answer of 6. So on the bottom I have 6, and on the top is 10 to the 1/3. Okay, that is one way to express this. Another equivalent way is 10 on the inside, the cube root on the outside, and 6 on the bottom. Either way is correct. Going on to number 6. Again, I'm going to start by rewriting this in rational exponent form. And I'm going to look into the fourth column because the nth root is 4. So on Monday's paper, referring back to those columns, Sebastian, you're going to help me once again. So I should have 16, right, Sebastian?
Yeah.
And then 81. Ooh, you're going to help me out. 256?
Yeah.
Okay. So we're going to do the same process that we did for number 5. I need to turn 4 into one of these. So I'm going to start, I know that 4 is located right here. And so I'm going to start one by one. I'm going to take this number and divide it by 4 until I find one that gives me an answer that is a whole number. So 16 divided by 4 just happens to give me a nice number. That means 4 times 4 is equal to 16. Times 4 times 4. You have to include the same rational exponent. 3 times 4, because you have the same rational exponent, you can multiply. 3 times 4 is 12. Include the exponent. 4 times 4 is 16. Include the exponent. So either look at the chart or use the calculator. If you're looking at the chart, find 16 in the fourth column, and you'll locate an answer of 2. If you don't have that chart, take 16 raised to the 1/4 power, and you'll get an answer of 2. So the denominator is 2, and you have 2 equivalent ways to write the numerator. This is one answer. Your other answer is the 4th root of 12 all over 2. Both equivalent and equal answers. Moving on to number 7. Number 7 and number 8. As a little review, you learned in 9th grade that when you have the same base and you're multiplying, you add the exponents. And you learned in 9th grade, when you have the same base, and you're dividing, you subtract the exponents. 9 minus 3 is 6. We're going to apply those same rules to what looks like a more complicated problem, but we're going to use the calculator to do much of the work. So the first thing I'm going to do is I'm going to rewrite these problems when necessary in rational exponent form. So the nth root is 20. 20 goes on the bottom, 1 on top. I do not need to change the next two. They're already in rational exponent form. On the bottom, I'm going to rewrite this as x to the 1/4. Remember, the nth root is 4. Okay, so I have the same base I'm multiplying. So I'm going to use the calculator, and I'm going to add these three together. So I'm going to start with 1 divided by 20 in parentheses, plus 3 divided by 5 in parentheses, plus negative 1 divided by 10 in parentheses. Then when I get an answer, I'm going to turn it back into a fraction by hitting Math, Fraction, Enter, Enter. So the numerator simplifies to x raised to the 11 over 20. In the denominator, I have x to the 1/4. Just like we spoke earlier, when you have the same base and you're multiplying, you add the exponents. The calculator did the work for us. Now when you have the same base and you're dividing, you subtract the exponents. So I'm going to subtract the top exponent from the bottom. So 11 divided by 20, subtract 1/4. 11 divided by 20, subtract 1/4. Let the calculator do the work for you. Then turn it back into a fraction by hitting Math, Fraction, Enter, Enter. So this final answer is x raised to the 3/10. Moving on to number 8. Number 8, again, is like number 7. First, I'm going to rewrite it in a rational exponent form. The nth root is 4, 1 on top. And on the bottom, the nth root is 8, 1 on top. So because I'm multiplying and I have the same base, I'm going to add the exponents. Turn it back into a fraction by hitting Math, Fraction, Enter, Enter. And 11 over 20 just happens to be the exact same problem as before. And I have it over x raised to the 1/8. When you have the same base and you're dividing, you subtract the exponents. So I'm going to take the top exponent in parentheses, subtract the bottom. Turn it back into a fraction by hitting Math, Fraction, Enter, Enter. 17 over 40.